Hi guys, today's Leetcode daily is longest nice subarray. So in this we are given an array nums which contains only positive integers. Now we have to find all the possible subarrays. For every subarray we'll do bitwise AND of every pair of elements in that. Now for some arrays we'll get this bit some subarray we'll get this bitwise AND of all the possible pairs equal to 0. So these subarrays we'll call as nice subarray and we have to return the length of the longest nice subarray. We know that the subarray is contiguous part of an array. That means if we talk about any subarray of an array, then we should take the indices in continuous manner. Like if there is an array of length 6, then we can call a part of array from index 2 to 5 as subarray, but not like that the array which contains second index, then fourth index, fifth index. There should not be any missing indices. Also it is given that subarray of length 1 are always considered as nice. Now we'll see example for better understanding of the question. Like this is nums array. Now among all the possible subarray, this is the subarray that satisfies the condition. Like if we do AND bitwise AND for all the possible pairs, then we'll get 0. Like 3 and 8 is 0, 3 and 48 is 0, 8 and 48 is 0. So since its length is 3, we'll return 3 as our answer. Now we'll see brute force approach. So we'll find all the possible subarrays. Now for every subarray, we'll take bitwise AND of all the possible pair of elements. Now the subarray with bitwise AND equal to 0 for all possible pairs will be valid subarray, that is nice subarray. So we'll return the length of the longest nice subarray. Now if we talk about time complexity, then finding all the subarray will involve O of n square, and for every subarray taking bitwise AND of all pairs of element will involve another O of n square. So overall time complexity will be O of n ki power 4, which is not feasible. So we'll try to do something better. Now we'll see sliding window approach. So if we have two numbers and whose bitwise AND is 0, then we can say that they should not have any common side width. Like these are the two numbers and their bitwise AND is 0, so they don't have any common side width. If they have any common side width, then their bitwise AND will not be 0. So we can say all the elements which are present in the nice subarray will have different set widths. So what we'll do, we'll take a sliding window, and in that window some elements will be there. For all elements there will be some set widths. So we'll maintain which all bits are set widths or which all bits are used by the set widths. Now if we want to add a new element and it has different set widths than the used widths, so this number to safely we can use add in the window, because if we'll do AND with all the numbers, since it has different set widths, we'll get 0 only. So like here we can see these two are the used widths, but new number has set widths at different width, so we can add this number. But programmatically how we'll know that we can add this number, we'll just do used widths and the new element. If their bitwise AND is equal to 0, then we can be sure that we can add that number. Now if new element contains some set widths that are already used, so what we'll do, we'll start removing the elements from the start of the window until the new number which we are trying to add has different set widths. Every time we add the element, we'll update length also accordingly, and at last we'll turn the maximum length. Now we'll see some properties of XOR. Like if we do XOR of any number with 0, we'll get that number itself. And if we get XOR of any number with itself, we'll get 0. Like 1 XOR 0 is 1 and 1 XOR 1 is 0. So this property we'll use to find our used bits. Like in the window, currently there would be no element, so all the used widths will be equal to 0. But when we'll add element, then it will have some set width, so used width also should have that set width. So we'll do XOR with used widths. then used bit will have that set width. Now when we are removing any number, then again we'll do XOR with used bits so that its effect get nullified and that set widths become 0. Now we'll see code for better understanding of the implementation part. So in the starting, we take used bits equal to 0. Since the our sliding window is of 0 size, there are no elements present in it, and initially answer is also equal to 0. Now we start traversing in nums. Now we are trying to add this new element to the window, but it is having some set widths that are already used. So we'll remove the element from start of the window until the new element have all the set widths that are unused. After that, when this new element will have all set widths unused, then we'll add this new element to our window and update our used widths accordingly. Now every time when we add new element, we'll also update our answer so that our answer always contains the max we have explored till now. After this loop is done, this answer variable will contain the length of longest nice subarray will return answer. Now, if we talk about time complexity, then there is only one loop which we traverse, so it is O of n, and we are not using any extra space, any extra vector or array. So space complexity is O of 1, which is constant. If you have understood this question, then please like, share, and comment on this video and subscribe my channel for more such videos. Thank you.